Welcome back, viewers, in the part 3 video of the Python program for finding the inverse of a matrix. We have already written this program in the previous video, and we are going to execute this for an example what we have seen in the first video of this part 1 of this series. Okay. Now, in the last video, we have seen that uh, if determinant is equals to 0, then it was executing the inverse part. So if determinant is equals to 0, it was also executing this. Okay, so for that we have used if determinant is equals to 0, it will print the inverse does not exist, and else it will print this. But we had an error in this also, so let me show you what is the error, right? So for that we will shift this further, and also we will shift this further, because both the commands has to be printed together. So if you see here, our entered matrix was 0, 0 first row and 0, 1 second row, and for that case we have calculated our determinant to be 0, and if it is 0, it will say that inverse does not exist as determinant is 0. Okay, and if we make our identity matrix again, we will see that entered matrix is the identity matrix. First row is 1 0 and the second row is 0 1. The determinant is 1. Now since the determinant is equals to 1, it will not satisfy this if condition. So it will jump this condition and directly go for the else statement. So else it will print the adjoint of a matrix and it will give the inverse of a matrix. Okay. Now let us put the example as a input what we have solved during the first part of this video. So let's go back in the first part and let's see the example. This was the example what we have used. So let us give this matrix as the input of that program. So let us write that matrix. The first vector is 1 minus 1 2. So 1 minus 1 2. The second vector is 3 1 0 3 1 0, and then third one is 0 minus 1 1 0 minus 1 and 1. Okay, let us execute this. Let us print this. Now if you see here, let me expand. Entered matrix is this. The determinant value is minus 2. Let us check our adjoint. Let us see our adjoint. Our adjoint was 1 minus 1 minus 2. So 1 minus 1 minus 2. Then minus 3 1 6, minus 3 1 6, and minus 3 1 4. So minus 3 1 4. And then since the determinant is not equals to 0, it will execute the adjoint as well as inverse. And the inverse of this will be, you are dividing this entire vectors by minus 2. So this is for minus 0.5. Let us go for the inverse here. 1 upon minus 1 by minus 2, that is minus 0.5. This will be minus becomes plus, so 0.5 and 1. So it is minus 0.5 0.5 1. Second vector, as you can see, it is 1.5 minus 0.5 and 3 minus 3. So 1.5 minus 0.5 and minus 3, and let's verify the last vector. This is plus 1.5 plus 1.5, then minus 0.5 minus 0.5, and 4 upon minus 2, that is minus 2 and minus 2. So this is how we have written the program for getting the inverse of a matrix by using Python, right? We can check this. We can make some modifications to this program as well. As I said in the previous video itself, that you can ask the user to enter the matrix, and based on that matrix you can manipulate somehow, do the respective changes, and you can give him the inverse of that matrix. Okay, so for that you use the integer and input function and ask the user what is the order of that matrix and get the inverse of that matrix. And the video on how to get the input from the user, it's already there in the playlist. You can go through that playlist. So this is all about our program on inverse of matrix. In the next video, we will see the transformations, elementary transformation. That means how to interchange two rows, or how to multiply a row by a constant, or how to add a multiple of some row to a particular row by using Python programming. So as we have done in today's class, same thing we will do in the next video as well. We will classify the next video into two parts. First part we will see the operations theoretically, and then in the second part we will write the Python program for it. So stay tuned and see you in the next video.